Newton's second law of motion says that a net force acting on an object will cause the object to accelerate in the direction of the net force. Remembering that net force is a combination of all the forces allows us to better understand this statement. So that means that the net force, the combination of the forces, if there is an unbalanced force, a net force of greater than 0, then there will be acceleration in the direction of the net force. This can help us calculate how much force we need to move an object with a given mass if we know what acceleration we want, because we can use the formula F equals ma, where F stands for force, m stands for mass, and a stands for acceleration. Mass must be given in kilograms, and acceleration must be given in meters per second squared, because we want our forces to end up in newtons. And a newton is equal to a kilogram meter per second squared. So if we're going to multiply our mass by acceleration, then we need our mass to be in kilograms, our acceleration to be in meters per second squared, so that we end up with a newton of force as our unit. This equation helps us to understand the relationships between force, mass, and acceleration, right? Force and mass have a direct relationship, meaning the greater your mass, the greater force you're going to have to use if you want to move that object with the same amount of acceleration. On the other hand, if you have a smaller mass, then you can use a smaller force and still get the same amount of acceleration. Force and acceleration also have a direct relationship, meaning that if I have a large force, then I'm going to accelerate that object faster. If my force is smaller, then my acceleration will be smaller. Mass and acceleration have an indirect relationship, meaning that if I have a very big mass, my acceleration is going to be pretty small. Direct. My acceleration is going to be smaller. On the other hand, if I have a really small mass, if my mass goes down, then the acceleration can go up. Those are indirect. So let's use this equation to help us work out this problem. How much force, that tells me I'm looking for force, would a tennis racket, sorry, that shouldn't have an E in it, would a tennis racket need in order to hit a ball with a mass of 0.06 kilograms and an acceleration of 5,000 meters per second per second. So I know I'm going to use force equals mass times acceleration, where my force is what I'm looking for. My mass right here tells me 0.06 kilograms, and my acceleration is 5,000 meters per second squared. So I can plug in force equals 0.06 kilograms times 5,000 meters per second squared, and I get a force of 300 newtons. Remembering that a newton is equal to kilograms times meters per second squared, which is what I have, kilograms times meters per second squared. Since weight is really just a force, it's a measure of the gravitational force on an object, we can use a similar equation for weight. Okay, we know what the gravitational acceleration is. We know that the acceleration due to gravity is 9.8 meters per second squared. Since weight is a force, we can say weight is equal to the mass of an object times the acceleration due to gravity, or times 9.8 meters per second squared. Let's do an example. What is the weight of a 35 kilogram object? Here's our mass. On Earth, since we're on Earth, we know that the acceleration due to gravity will be 9.8 meters per second squared. So if I wanted my weight, I know I'm going to use mass times acceleration due to gravity, where weight is what I'm looking for. Mass is 35 grams, and my acceleration due to gravity is 9.8 meters per second squared. So I can plug in weight equals 35 kilograms times 9.8 meters per second squared. And I will get that the weight is equal to 343 kilograms times meters per second squared. Remembering that kilograms times meters per second squared is a Newton. My weight is 343 newtons for a 35 kilogram object. Since I have two sig figs here, this is a given, so we don't have to count them in our sig figs, but there's two there as well. I should have two in my answer, so my sig fig answer should be 340 newtons of force. That would be my weight. Okay, so in your notes, you should have the second law, what it says, the equation. You should know the relationship between force, mass, and acceleration. You should be able to calculate force, and you should also be able to calculate weight. It is important that you realize that mass and weight are different, right? Mass is the measurement of how much matter, meaning how many particles, atoms, compounds are in there. Weight is the force of gravity. And it is because of the mass, right, times the acceleration due to gravity.